Now we'll move on to the topic. So your last topic in Unit 5 is cyclic code. The cyclic code is one of the type of linear block code. Okay, so it is one of the type of block code. Okay, so already we have seen what is a block code and how to generate a generator matrix. From the generator matrix, how to generate the code words. In the code words, how to find the errors. Is it? So these are the topics already we have discussed in the first one, that is block code. Okay, now cyclic code is a type of linear block code. So this cyclic code will satisfy two property. Okay, so one property, sorry, okay, one property is a linearity property. Okay, another property is the cyclic property. Okay, so previously we have discussed linear block code that satisfies only linear property. So what is linear property? If I add two code words, it will generate a new code word. Okay, that is the property we have discussed. Okay, so the sum of any two code words will set to be will generate a new code word. Okay, so this property is also satisfied by this cyclic code. Okay, here we are saying the term add, but actually it means modular to addition. Okay, so your cyclic code satisfies the first property is linear property. Next one is cyclic property. So cyclic property in the sense, if this is a code word I'm generating x1, x2, x3. Similarly, I'm generating up to xn minus 1. Okay, so the cyclic second property is the circular shift of each code word gives another code word. Okay, so the circular shift of each code word here x minus 1 is again shifted here. So it will generate a new code word. Okay, so that is a second property. The circular shift of each code word gives the another code word. Okay, these are the two property satisfied by a cyclic code. So the cyclic code will generate, we can generate a code word by using two methods. One is systematic method and the one is a non-systematic method. So we will discuss this one in the next problem. Okay, so I will tell you the formula and we will discuss the problem. Now this is the question they will give you. The generated polynomial 7, 4 cyclic code is g of p, which is equal to pq plus p plus 1. Okay, find the code word using systematic and non-systematic code. So whenever the question is given, so I told you cyclic code is a type of block code. Always block code representation is n comma k. So in your question they have given it is 7 comma 4. From that you can identify n is equal to 7 and k is equal to 4. Okay, by using this two value, you have to find q. Because in a block code, you will have a message bit that is represented as a K and you will have a check bit that is represented as a Q. The total length of the block is N. That is total number of bits in your code word is N. Okay, so your whatever code word you are generating that will have 7 bits. In that 4 bits are message bit. So in order to find Q, the formula is N minus K. So 7 minus 4 is equal to 3. Okay, so these three are represented as check bits, or you can say it is a redundant bits that is included along with your message. Okay, in order to provide security. Okay, so suppose if any third party is trying to hack our message, this check bits will provide security to our message. Okay, that's why we are combining a message signal with the check bits. So check bits will be generated by our own. Okay, so here we must generate at least 3 bits of check bits. Okay, so that is the value of Q. Okay, this is the concept we have studied in linear block code also. So this is the first step. N and K will be given. From that you have to find Q. So I will write here K is the number of message bits and Q is the number of check bits. and k is the n is the number of bits available in your code word. Okay, now we will see this method one by one. First, I will discuss the non-systematic code. So for both the method, first you have to prepare a tabulation like this. Okay, in your tabulation, your first column is your message bit. Okay, your message bit here, according to your question, your number of message bit is 4. Okay, so k value is 4. So you have to write M0, M1, M2, M3. Listen carefully. You should write in a reverse order. Okay, wherein linear block code we have written in a normal case, that is M0 first, M1, M2 followed by M3. But here in cyclic code, so M3, M2, M1, M0. So this is the order you have to arrange for your message bits. Okay, and here since k is equal to 4, you will get 16 combinations from 000 to 111. Okay, if k is equal to 3, you have to write 8 combination. So this is the first column in your tabulation. And next column is I am going to generate the code word by using non-systematic method. Okay, so here how many bits are there now? Your total code word length. Your total code word length according to your problem is n is equal to 7. Okay, so x6, x5, x4, x3, x2, x1 and x0. Okay, total 7 bits are there in your code word. Same length is for systematic also. Systematic code word also, the code word will have 7 bits. Okay, so that is also x6, x5, x4, x3, x2, x1, x0. Okay, but here I have written m3, m2. That is nothing but, we all know that code word is nothing but combination of message bit and check bits. Okay, that's why I have written like this. Okay, so for systematic code you can write like this. For non-systematic code you just simply write from s6 to x0. Okay, so form a tabulation. Then for each and every message bits, we are going to find a code word. Okay, first let us discuss what is this non-systematic form. So the non-systematic form will not follow any rule. Okay, the formula to calculate code word is, so x of p is your code word. Okay, the code word polynomial you have to calculate as multiply g of p and m of p. So g of p will be given in your question. Okay, pq plus p plus 1. So pq plus p plus 1. Only this m of p value will be vary. Okay, for this you will have separate polynomial. For this message vector you have separate polynomial. For similarly for each message sequence having different polynomial. Okay, first if I have written the polynomial, so it is 0 0 0 0, that is p3, p2, p1, sorry, and 1. Sorry, p cube, p square, p and 1. Okay, so this formula we have used in convolution code also. In convolution code, we have used an approach, transform domain approach. So there also we have used the same formula. Okay, the difference between the cyclic code and convolution code representation here is, there you have considered formula. If suppose this is the code word, this is a message sequence, now you will consider 1 p square p cube. Okay, in this way you will consider, but in cyclic code in reverse order, p cube, p square, p and 1. So there is no 1, so your message polynomial is 0. 0 0 0 1. Now only your constant is available, the value is 1. So 0 0 1 0 of the message sequence, now the 1 is available only for p, so your polynomial is p. 0 0 1 1, now p and 1 is available, so your polynomial is p plus 1. Okay, 0 1 0 0, now it is p square is available, so it is p square. Similarly, if it is 1 1 0 1, 1 1 0 1, now p cube is available, p square is available, p is not available, then your constant. Okay, similarly, you have to write for all 16 combinations p square, p plus 1. So this is the message polynomial for your 16 combination. Here I have written only for few examples. You have to write for all the message, for the all the message sequence. Okay, if you want, here itself you can include one column. Okay, the column name is message polynomial. Okay, represented as a message polynomial. So message polynomial, the column should be P3, P square, Pn1. Okay, you have to include like this. So first column is your message sequence or message vector. There it is M3, M2, M1, M0. Then your second column is your message polynomial. So message polynomial is PQ, P square, Pn1. Okay, so for your corresponding message sequence, you have to write what is your polynomial. There's a polynomial here is P. Okay, this column you have to include. Here I have didn't include. If you want, include. Okay, or else directly you can consider your sequence and you can write a polynomial and do a problem. Okay, any doubt in this step? Any doubt in this step? Any doubt now? First and second column, any doubt?
No,
Now any okay, now anyone will you say what is the polynomial for 0, 1, 1, 0?
P square plus P.
Good. Okay, so it is very easy. First step, you have to write the polynomial for all your message sequence. Then now substitute in your formula. Okay, so you have to find the code word for every message sequence. Okay, so let us solve at least 3 to 4 cases. Let us consider this 0, 1, 1, 0. Okay, so your message sequence is 0, 1, 1, 0. And first step is you have to find the polynomial for a message sequence PQ, P square, Pn1. So your formula is P square plus P. Okay. Now I'm going to find the code word for this corresponding message sequence. So it is G of P into M of P. So G of P is given PQ plus P plus 1 and M of P is P square plus P. Okay. So according to this problem, the concept is very easy, but it will take some time because we have to find for all 16 combination. So it takes some time. Okay. So multiply this two. So p cube with everyone now p power 5 plus p power 4 plus p cube plus p square plus p square plus p. Okay, while multiplying, add your powers. Okay, now you can see here. I will tell you the shortcut. That is, you all know that is here I have written plus, but I told you it is actually modulo to addition. Modulo to addition is nothing but your XOR operation. The XOR operation here a shortcut is if the term occurred odd times now, then the term will be available. If the term occurred even times, then it will not be available. Okay, it is 0. Okay, here it is 1, here it is 0. This is the concept. Okay, now you can see here P5. So P5 is available only one time, odd time, and P4 also available one time. P cube also available one time, where P square is even times it occurs. So you have to cancel that last P. Okay, now I'm going to find the code word. Okay, so code word here we must know that what is the length of the code word? It should be 7. Okay, length of the code word should be 7. So it should have 1, P, P square, P cube, P4, P5 and P6. Okay, so you have to write the value for n is equal to 7. Okay, so constant is not available, P is available, P square is not available, P cube, P4, P5 is available, P6 is not available. So this is the code word for your message sequence 0110. Any doubt? You can see 0111010. 0111010. Any doubt now? Shall I solve one more message sequence? I hope you can try it. It is very easy, right? So you please try for this 1100. So 1100. Okay, immediately write your polynomial p square p and 1. The polynomial here is p cube plus p square. Will you please find what is your x of p? I will write the formula, then you can proceed. Okay. Will you please proceed and say the answer? If you have doubt, I will repeat the same sequence again. Then you can do this. Now we all finished.
Yes,
So
ma'am.
you have to practice. Yes, ma'am. Thank you. What is the polynomial first one?
P6 plus P5 plus P4 plus P3 plus P3 plus P2. P, P3 and P3 will cancel.
P3,
So P6 plus
P2.
P5.
Okay. So this is your polynomial, final polynomial, right? So here your x must be P6, P5, P4, P3, P2, P and 1. Okay, so no need to write this. Okay, just for reference here I am writing. In exam, if you want, you can write. So P6 is available, P5 is available, 4, 3 is not available, 2, 0. Okay, so 111, 0, 1, 0, 0. 111, 0, 1. Very good, very good. What is your name, ma?
Hema, ma'am.
Okay, good, good, Hema. So students, hope you understand. Here I have considered only 2 examples. Similarly, for all message sequence, first step you write the polynomial. Okay, then you find out the code word. Okay, so this is the non-systematic method. Hope you understood. Shall I move to systematic? Voice side, will you please respond? Shall I move to systematic? Hope you understand one non-systematic method. Voice side. At least respond. If you have doubt, you can ask. Any doubt, boys? ஏன் இவ்வளோ ஹெசிடேட் ஆறீங்க ஒரு டவுட் இருக்கா இல்லையா இல்ல புரிஞ்சுதா இது சொல்றதுக்கு ஏன் இவ்வளோ ஹெசிடேட் ஆறீங்க ம் டோன்ட் நோ when you are going to change your attitude இப்படியே இருந்தீங்கன்னா ரொம்ப கஷ்டம் ஓகே no problem you will face everything when you have joined a company okay கம்பெனில எங்களை மாதிரியே இவ்வளவு சாஃப்டாலாம் யாரும் பேசிட்டு இருக்க மாட்டாங்க ம் அந்த டைம் you will face the issue okay now non systematic the formula here you have to generate the code word okay by combining your message bits and then check bits okay message bits will be given you have to combine both your sorry it is not a polynomial okay your code word x is nothing but combining message and your check bits okay we must know your message bit k value is 4 and your q value is 3 okay so message sequence is given okay it's already there in a tabulation simple thing is you have to find your check bits for non-system for systematic code your first step is what is your message sequence that you have to write it first okay so என்ன எழுதிருக்கீங்களோ from 0 ல இருந்து 1 1 வரை first எழுதிடு okay the remaining thing you have to calculate is only your check bits C2 C1 C0 okay because your q value is 3 here so C2 C1 C0 that only we are going to calculate so the formula to find your check bits okay formula here is here also it is a formula using polynomial only so remainder of p power cube m of p divided by g of p okay we all know what is q it is 3 So remainder of p power cube into m of p divided by g of p. Okay, so first you have to divide this both, then the remainder will be considered as your check bit polynomial. Okay, this is the process. Yeah, this is the procedure you have to find your C of P. Okay, so let us do one by one. So as usual, your generator polynomial will be given in your question. Only your M of P will be varied based on your message sequence. Okay, now let us consider the same message sequence 0, 1, 1, 0. 0, 1, 1, 0. And of course, we all know the polynomial. It is P square plus P. Okay, now I'm going to find the polynomial for check bits. So it is remainder of p power q value is 3, then m of p divided by g of p. Okay, so it is the remainder of p power 5 plus p cube, p3 plus p plus 1. So I'm going to divide this both, the remainder will be considered. So let us do the division.
Ma'am,
So your yes, ma'am.
p power 4, ma'am. P power 5 plus p power 4.
Yeah, okay, okay, thank you so much. So here p cube is available, p square is not available, p is available, and constant is available. So while doing division, you have to expand in this way. Okay, whichever term is not available, you have to include the term also, that is 0 into p square. Similarly, you have to expand this also. Okay, so it is p power 5, p power 4 is available, but p3 is not available, p square is not available, p is also not available, and constant is also not available. So these two terms are available. Okay, this is the expansion of this polynomial. Now you have to do your division. Okay, this you all know. Your first term you have to get here. So if I multiply p square with p cube, you will get first term. Okay, so remaining term is 0 p square 1 into p cube, sorry, 1 into p cube, then 1 into p square. Okay, so this is your answer. Now you can see here also 1, here also 1. Okay, we all know the XOR operation 0, 0, 0, 1, 1, 0, 1, 1. So it is 0, 0 and here it is 1, 1. So here also 1, here also 1. So it occurs even times, right? So the term will get cancelled. Where here it is 1, where here it is 0. Sorry, it is 4. So here it is 1, here it is 0. So the term will be available P4. And here also 0, 1. 0, 1, the term will be available. Okay. And here also 0, 1, the term will be available. And the remaining terms are 0p and constant. So 0p plus 0. Okay. Now your first term is P4. In order to get P4, I have to multiply P with this PQ. Okay. So PQ is p power 4, 1 into p power 4 remainder, then 0 into p cube, 1 into p square and p, 1 into p. Okay, this is your answer. So here and all you have 1. So 1, 1, the term will get cancelled. 1, 0 now, you will get the term. 1, 1 get cancelled. 0, 1 now, you will get the term 0p plus 0. Further, we can continue this because here your highest power is P3. We can continue that division. So it is multiplied with 1 will give you the first term P cube. Okay. So it is 0 P square, right? 0 P square. And here it is 1 P square, 1 P plus 1. This is your answer. So P cube plus 0 P square, P plus 1. So 1, 1, this term will cancel. 0, 1, the term will be there. 0, 1 and 0, 1. So this is your answer. Your answer here is p squared, p and 1. All the terms are available. I told you for the check bits, the number of bits must be there, that is values q equal to 3. Okay, so in your check bits, the polynomial is p square plus p plus 1. So c is equal to 1, 1, 1. All the values are available. Okay, so how to write the answer now? Here, for the corresponding message bits 0, 1, 1, 0, I'm getting the check bits 111. Okay, this is your code word. If you count the number of bits 1, 2, 3, 4, 5, 6, 7. So your answer is correct. You must have 7 bits. In that 4 bits are message bit, remaining 3 bits are check bits. Okay. So 0, 1, 1. One into 0 into 1, it is 4 plus 1 plus 1. Two. Sorry, your answer is 1. Okay, your answer is 1. So here your answer is 0, 0, 1. Sorry. Okay. So p square, p term all get cancelled. Only a constant is available. So it is 0, 0, 1. Okay, what mistake I did now? Here it is 0 and 1 will give you 1p, right? So, and here what I did mistake now? So 0 into the 0 p square into 1 is 0 p square. Okay. So this is your answer. Okay. Now, will you please do for will you please do for 1110? Please do for 1110. First write the polynomial. Okay, then proceed with your formula. Any doubt on this long division method? This you have studied in signal system. So the step here is first you have to write the message polynomial, then you have to multiply the message polynomial with the p power q and then divide by g of p. Okay, while doing division, you have to expand and then do your division. Okay.
C value, oh ma'am, 001, it's triple one.
Now you can see here, here it is 0 p square, right? So 0 p square, and here you will have 1 p. So 1 p now, yeah. So 0, 0, 1. Yeah, 0, 1, 1, 0. The answer is 0, 0, 1. What I did is correct only. Will you please check once again?
Okay, ma'am, with according to reminder, we should check that.
Okay. What I did is correct. Okay, your answer is 0, 0, 1, 1. Previously, what mistake I did now? Here, I've written 0p. So 0p and 1p will give you 1p, right? And similarly, here also I've written 1p square. 0 and 1 will give you p square. So this two mistake I've done. Oh, this is the correct answer. You please proceed with this subject. And in university exam, if they didn't mention any method, you please prefer non-systematic method. Okay? Systematic question paper கேட்டா மட்டும் solve பண்ணுங்க இல்லனா பண்ண வேண்டாம். A systematic method, it takes more time. Concept is very easy, but கொஞ்சம் time எடுத்துக்கும். For systematic, at least we solve for 2 or 3 cases. Up-down Puri. What message sequence I given? 1110, right? So 1110. Solve for 1010. For this two message sequence, please calculate code word. Akash, are you there? Akash, number 17. Akash, are you there? Pa? Dinesh D. Okay, at least whoever is listening, you please do it and say the answer. And listen, students, one point you have to remember, while after doing division, you have to consider the remainder only. Don't consider quotient, okay? So your remainder here is 1. That's why I'm substituting 0. That's why I'm putting 001. You don't consider quotient. Okay, so if you consider quotient, your answer is 111. You don't consider that. Always consider the remainder. Finished? What is the answer for this? 1110?
1
1, na?
p square plus 0.
P square plus 0. The answer is 100. Okay, 1110, it is 100. It's good. 1110 is 100. Very good. Similarly, calculate for 1010. So students, in remainder, if you are getting more than p square, then your answer is wrong. Okay, your answer in remainder, your polynomial should start from p square. Okay, that is very important. If you are getting remainder like this, na, then it is totally wrong. Okay.
P plus 1.
P plus 1 na? So P plus 1 na, the answer is 0, 1, 1. 1, 0, 1, 0. So 0, 1, 1. Good. Your answer is correct. So now you understood how to do both systematic and non-systematic. Similarly, you have to do for all message sequence. Okay. In 2 mark, if they have asked this question, you have to consider any one message sequence and find the code word. Okay, 1 or 2 message sequence you can consider and find the code word. So that's it. Any doubt, students? So now you are going to draw the encoder diagram for your cyclic code. Okay. In previous linear blockout topic and also in convolution encoder, we have drawn the encoder diagram. Similarly, for cyclic code also, there is an encoder diagram. So here you will have a flip-flop. Okay, that is a one block I'm using. And you will have a multiplying coefficient, that is G1. Okay, G2, G3, etc. So this is the multiplying coefficient. Okay, and you have a modulo addition. Okay, so you have flip-flop. You have a multiplying coefficient. And next one is your modulo to add. So these are the 3 components we are using in your encoder. This is also an important 2-mark question. What are the blocks are used in encoder? For cyclic code, na, these are 3 blocks. By using this, we are going to design. So your diagram here is, you have a flip-flop. Okay. You can consider any number of flip-flop based on your question. Okay, if your m is equal to 4, you have to consider 4 flip-flop. Your m equal to 3, you have to consider 3 flip-flop. Similarly, you have to consider many number of flip-flop based on your message sequence. So then you have to use modulo 2 addition in between flip-flops. Sorry, I will write here. So this modulo 2 addition. Okay, similarly, you have to continue for remaining cases. Okay. So in this modulo 2 addition, what you are going to add now? You are going to add this multiplying coefficient. Okay, so the multiplying coefficient is G1 and your multiplying coefficient is G2. Similarly, you have to continue up to G n minus k minus 1. Okay, so along with your flip-flop output, you have to multiply your G1 coefficient. Okay, so this is your diagram. Okay, so this is your encoder diagram. So you will have flip-flop and model 2 added, and then your multiplying coefficients. Okay, so then you will get 2 bits, that is a check bits and message bits. In your code, will have both the bits. Is it? So whenever message bits you are sending, you have to link message bit to this circuit. Whenever check bits you are transmitting, you have to link this check bit switch to your system. Okay, so this is your encoder diagram. Okay, so in next class we will see how to solve problem in your decoding part. Okay, so in